Welcome. So in this video, we'll be answering question 8 here. It says, sketch the graph of this and find the area enclosed by the x-axis and the portion of the curve above the x-axis. Okay, so let's begin by sketching this. So I'm going to begin by just writing it out. I have y is equal to 5x minus x squared minus 4. Now, the first thing I need to do is find my x-intercept. So to find my x-int, I'm going to let y equal 0. And I'm going to get 5x minus x squared minus 4. Now here's the really important thing. When you're trying to find the x-intercept, and you've got it in this form right here, what you're going to be doing when finding it is you're going to factorize. So you have to factorize it. So we're going to have to go through that process. Now, the first thing I would want to do here is just rearrange it. So my x squared term is at the front. That just makes a little bit more sense in my brain. Also, when I'm factorizing it, I don't like my x squared term to have a negative there. So what I'm going to do is I'm just going to take that negative out. I'll just leave it there for now, which will change the signs of everything inside, but that's fine. The next thing I'm going to do after I've done that is I'm going to have to figure out how to factorize this thing, the important part now. A really good way that I find to do this, and again, people have different ways, is to go, well, my product needs to be 4. My sum needs to be -5. What two numbers can I multiply together to get 4 and add together to get -5? And my answer to that is going to be -4 and -1, because -4 times -1 is +4, and -4 plus -1 is -5. Then once I've done that, I can come here and I can go, right, 0 is going to be equal to negative x minus 4, x minus 1. And you've got to make sure that this whole thing is in brackets because it's all inside that. Now I can look at this and I can use my null factor law to tell me what my x-intercepts are going to be. My x-intercepts are going to be 4 and 1. So now I can come over here, I can draw myself a pair of axes like such. Let me try that again. Let me go from here to here, from here to here. I'm going to go, now I have 1 here, and I have 1 here, so 1 and 4. I also know that this is a quadratic, and the negative in front of it is telling me that it's reflected in the x-axis, right? So it's going to look something like this. Whoa, my computer has some serious lag going on. Let's try that again. Look at that lag. All right. That is as good as it's going to get. Try to make your graph as pretty as possible. I'm not going to fully sketch this. I think that will suffice. So I'm not going to find the y-intercept because at the end of the day, we're just doing this for the purpose of finding this right here because it's the area enclosed by the x-axis and this. So maybe the back of the book wants us to find the y-intercept, but we could do it actually very easily. If you set x equal to 0, it's going to be -4. So let's just do that anyway. It's going to be -4, and I'd have to write it as 0, -4. So remember, this would be 1, 0, and this is 4, 0. That point. Perfect. So we've drawn it all nicely there. Nothing too tricky. Now we're going to have to do the tricky part, and that is figuring out the area bounded. So how are we going to do this? To figure out what the area bounded is going to be, let me grab my pen. I'm going to be finding the definite integral from 4 to 1, because that's where I'm going from 4 to 1, of this right here. I would write it as -x squared plus 5x minus 4 dx. All right, the next thing I'm going to do is I'm going to anti-differentiate this. So come here, go there. If I anti-differentiate it, it's going to be x to the 3 on 3 because I plus 1 to the power and divide by that new power. This will be 5x squared to the 2. This will be minus 4x, like that. And this is from 4 to 1. All right, let's keep on going. I'm now going to sub in my 4 value into this. And just to make this a bit clearer, let's color code it, shall we? Why not? Let's make this in orange. And let's make the other one in purple. 4 to 1. So the first thing I do is I sub in my top one. So I'm going to get -4 cubed over 3 plus 5 to the 4 squared on 2 minus 4 to the 4, close, close. And now I'm going to subtract from that what happens when I sub in my 1 value into this. So it's going to be negative 1 cubed over 3 plus 5, 1 squared over 2 minus 4, 1. All right, we're going well. Let's keep on going now. Let's hope we don't make any silly mistakes here. 4 cubed is 64, so it's going to be negative 64 on 3 plus 5 squared is 16. Sorry, 4 squared is 16 plus 5 is 80. 80 on 2. If you're struggling with that, in my head, what I'm doing is 4 squared is 16 times 5, right? Then I went 5 tens are 50, 5 sixes are 30, and when I add those together, I get 80. So after a while, you can just do those in your head. Why doesn't it rub out? Stupid computer. This is going to be minus 16. Close, close. And then I'm subtracting from that. If I come over here now, this is just a lot of legwork now. This is negative 1/3. This is 5 on 2 minus 4. And I'm going to write this as 4 on 1 because I know what I'm going to have to end up doing is making all of these common denominators, which is going to be a pain. All of them are going to have to be common denominators of 6, right? So I'm going to have to times this by 2. I'm going to have to times this by 3. I'm going to have to times this by 6, right? That's a pain. All right, we're going to keep on going. We're continuing on this way. This is negative 64 on 3 plus, now this is going to be 80 on 2 is 40, right? 40 minus 16. And then on this side over here, I'm making everything have the same denominator. So this is going to be negative 2 on 6 plus 15 on 6 minus 24 on 6, like that. We keep on going here. We keep on going. This is just a painful question now. We've kind of done the hard part. This is now just making sure we don't slip up with our calculations here. 40 minus 16 is going to be plus 24. Now I'm going to have to make that have a common denominator of 3, right? In order to do this addition here. So that means I'm going to have to times this by 3 and this by 3. We'll come back to that later. Let's keep on moving along this way. Let's grab my purple out again. All right, what is negative 2 plus 15 minus 24? Well, let's think it through. Negative 24 and negative 2 minus negative 24, that's going to be negative 26, right? And then negative 26, 15 minus 26 is going to be negative 11 on 6. So don't get tripped up there with all those funny numbers going on. Another way you could think about it is negative 2 plus 15 would be 13. And then 13 minus 24 would be negative 11 on 6. But as long as you don't make a mistake, whatever way you do, it's fine. All right, then we're here. This is now negative 64 on 3. 24 times 3 is 72. And that will be 72 on 3. And then on this side now, those two negatives are going to make a positive, right? So it's going to be plus 11 on 6. My goodness, what a horrible question this is. Who'd made this? Now I've got 64, negative 64 plus 72. That's going to be 8 on 3. And then I've got plus 11 on 6. I'm going to have to find a new color now. I reckon we go back to black because I'm about to join these together. Now, before I join them together, I'm actually have to do one thing before I do that. And that is I'm going to have to times this by 2 to get common denominators. Whoops. This one. 2 times 8 is 16. This is 6 plus 11 on 6. My answer, people, is going to be 27 on 6, which can then be further simplified. I can divide the top and the bottom by 3. Where's that black one? This is going to be 27 divided by 3 is 9. 6 divided by 3 is 2. So it's going to be 9 on 2, also known as 4.5. Either of those would be fine. And that's how you do it. Booped, booped, booped. And that is how you do it, people. 9 on 2, 4.5. Look at all that beautiful working that we have done. to answer this question. Now, if you wanted to, we could do this on the CAS. And I think it's really important that as you're doing your exercise, that you make sure that you've got your CAS with you, so you can just double check what you're doing as you're doing it. So let's give this a crack on our CAS, shall we? So I'm going to come and open up a new page. Whoopsie daisy, it's not what I wanted to do. Whoops. Let me just come here. That one. All right. To get a definite integral up, I would go Shift plus, and then this comes up here. I'm going from 4 to 1. So I'm going to put a 4 there. I'll put a 1 there. And then I'll put in what I am anti-differentiating here. So it's going to be negative x squared plus 5x minus 4. I'll put an x here. Good. Just double checking what I'm writing. That all looks good. I hit enter. I get 902. And would you look at all that working? Look how quickly my CAS did it. Put me to shame. That's for sure. That's a great way to do it. Another way to do it, which I wouldn't really recommend do it this way, but another way to do it is, especially if we want to think about it graphically, if I go Control Doc, let's add a graph, and then if I come here for a second and I just remember your CAS is a computer, so I can come here, I can just go Control C, then come here, then go Control V, then I can hit enter. And as you can see, this is the graph that we were given before. Analyze graph. Actually, let me just zoom in a bit here. Let me come to the box. Let me just zoom in like that. And now what I can do, now I know my points are from 1 to 4, right? That's my X-intercepts. Let me get rid of that. I can go this. I can go menu. I can go analyze graph. I can go integral. Now, my lower bound, I don't actually want to, I could do intersection point like that. I much prefer just to go 1, enter, and then I'm going to 4, enter. And would you look at that? 4.5. This is another way to do it. Another legitimate way to do it. If you want to do it that way, you can feel free to do it that way, but it's far more important that you can do it this way, and that's worked out well as well. Remember, if you wanted your answer as 4.5 instead of 902, you'd have to hit Control, then enter, then you get it as 4.5. I'm trying to think of anything else I could show you how to do here, but I think that's pretty much it. Make sure you're using your CAS efficiently. Make sure you're being careful with your calculations. Hopefully you found this video useful, and I'll see you in the next one.